Good morning, good morning. Happy Tuesday. Hello, Bear Cool. How are you doing today? I was watching a little bit as I was making dinner last night. Are you still working on the event system with Twitch for like the event bot? Combining it with a chat bot? Yeah, more or less. Awesome. How's it going? Like it looks like it's coming along nicely. Um, what are we working on today? We are working on evaluating, let's see. Somewhere between Chatty and WeChat. I have not used either of those products, so I have no idea what that would be like. Let's see. So today we're gonna be testing and like playing around with performance, specifically around draws. So let's create a new project here. So we do cargo new exploring I guess it's specifically draw performance. GGEZ, okay. And we'll go ahead and open up code. You'd be a lot further if you didn't have to fight migraine stuff. I'm sorry about that. Hopefully things will, like, I don't know, like, I've not had migraines myself, but like everyone that I know that has them, it can be really devastating. So I'm sorry you have to deal with that. All right, so we're gonna pull in GGEZ, and we're also gonna pull in ECS. And we have that nice 0.2. Okay, so let's go ahead and get ourselves set up. We're gonna have a live.s, and inside of here, we're gonna have our pub struct. This is just gonna be our main state. We need to impl. Oh, I have to wait for Rust Analyzer to finish updating after the pulling in crates. All right, so we're going to implement the event handler for main state. That's going to give us the update and the draw loops. So for update, we don't have to do anything this second. Bring you in. And for context, I guess we can underscore it so we don't get the warning. For you, we definitely need context here. Okay, so for draw, we're gonna first, I guess we can create like a static black background. So that will be graphics, clear, context, and black. And graphics present, context, and that returns a result. Okay, so we're good here. Let's also impl main state. I don't know if we need to well, I guess we're probably gonna do a bunch of things with like context in here. So let's have a context come in. After that, I don't know if we need to pull anything in here, so we'll go ahead and return a Oh, we need error. We'll return an error result. In this case with a self inside. All right, easy enough for right now. And we can go ahead and underscore the context. It'll just be nice for us to have that passed in for when we do have to make like a bunch of meshes and other things. All right, on to main RS. So the first thing we need to do is set up our window and let's see, what is it? It's the window state and the window setup. So window mode and window setup. Do window setup first. Do a default. And are you going to tell me what we can do here? Sort of, yeah. We have a title that we can set. So this is going to be exploring draw performance. What else do we want to do? Pretty much that's it. Okay, so view that window mode. It's window mode. Alt dot. Oh, it's so nice. It actually tells us what our options are now. That's a great update for our Rust Analyzer. I don't know if like it was this version or a couple of versions back, but this is really nice. So what this means is we can do some dimensions here. So we can do sizable min height. Can like get the width. I don't think I want to make this one resizable. We're gonna make this just the normal size and just like stick with it because we're not really testing resizing. I'm looking at the wrong thing. I'm looking at blue, and I think I want to look at these. So we have dimensions. So we can set what the dimensions are. I believe we're streaming out at 1920 by 1080. So let's just do the same that we're streaming out at. And I wonder if I want to try to do a like a full size with this, like a full screen. Because we could do a full screen type. Full screen type desktop? Can we set full screen? I don't think we can do full screen here. Maximized. I guess we could do maximized. Maximized is true. So let's try having everything like start with full screen mode. So we create our window setup, we create our window mode. Now we can do a let our context, and we have our event loop equals. This is event. Oh, context creator. Context builder. New. Window mode. Mode. Setup. We build you. You return a game result, so we can actually return a game result from here. And then question mark it. All right, so that gives us context and events loop, which means we can now use that. Oh, then we need to get our game state. I guess this is like the main state, is what I called it. Main state equals main state, new, and pass it a mutable reference to the context. I cannot do a question mark here because we're returning a game result here. You know what? I can probably return a result like that and still do the question mark. It just means at the very end, we have to do an okay. What are you upset about? New takes 2 arguments. Oh, right. New is like the name of the game file that it registers. So the name of the game it registers with the operating system. So this is going to be BB exploring performance. And then the name of the creator. Me. All right, that should make you happy. You need to be mutable. I think I put that in here, right? You need to be mutable too. All right, then you're just saying that we're not using you. Okay, perfect. Then we can do event run. Okay, pass in mutable reference to the context. Pass in mutable reference to the event loop. Pass in a mutable reference to main state. And I think we're good to go. I think we're good to go. So we're not using you. And if we run you, I'm curious whether or not it will actually go to full screen or not. Maybe? I guess I could have done a vote on it too. What with our compile time? Oh, it does. Okay, so it totally goes into full screen. Perfect. So then, what I want to do with that is we want to start like figuring out how we're going to do our test here. I'm thinking of just particles, tons and tons of particles. We're not necessarily testing like how to make the update loop faster. So far from what we've seen is we cannot care that much about how efficient our algorithms are, and we're fast enough, at least on like Windows computers, like decent Windows computers. It's that draw that really gets us right now. So to deal with that, I'm thinking let's create like 1,000 or more particles. We can just keep on increasing the number of them until it doesn't work for us. We'll start them at the bottom of the screen, and we can have them like float upwards. We can even do like, just to make them look nicer, we can even do something with how like their colors, and we can have like some purlin noise or something, blow them around. It could be interesting. I'm thinking of making them all sort of like mostly red, in order to give it sort of like that fire look. I think that would be really sort of striking against the black background. So to begin with, we're gonna have to store a world. All right, so we're creating the new world and storing that away. And that means in update, we also have to update the world. So wait, does update? Oh, it return. Oh, but it doesn't return a game result. So this has to be unwrapped. Okay. Now, next thing that we need to do. Oh, we need to start like putting entities in here for us to care about. So I'm thinking we're only gonna have like one essentially type of particle. Let's register a new component we're gonna have. I guess we're gonna have a bunch of components. We need things like our location, we need velocity and acceleration, stuff like that for us to sort of move on upwards. So I'm gonna have let that register. So let's start with a location. And I'm thinking for this first version, we're also gonna put the mesh inside because I want to like recreate what we found last time and get it where we have like our draw just huge. So world dot, because I guess like what do we need to actually display something out? We need a location. We need a mesh essentially. So if we do that, then let's create a single item in here. So that guess our location is going to be a new point. Let's just put it somewhere arbitrary. So like I don't know, 50.0. We need the mesh also. It's gonna be a mesh builder. Gonna make you a circle. Draw mode fill. Our point. Let's put this in absolutely just like the top left corner, and we're going to translate that at draw time. Radius. I want you to be maybe like a 5.0. 1 for tolerance and color. Let's actually create a color here. We can make this not completely super bright red. It could be something like 0.9. That will give us hopefully sort of like a dullish red. Then, but still bright enough to see easily. Then we'll pass in the color here. Build you. Pass in that context we need. And there we go. We need to pull in draw mode. All right, so we have a color, we have a mesh. So location is that, mesh is that. That seems to be fine so far. I don't know if I need anything else just to begin with. So once we create those, we're going to insert them into the world. So world.spawn entity with component, location, and our data is going to be the location. Then we're going to have the mesh, and the data is going to be the mesh. All right, so we have a single component, a single entity created for us. If I want to create a draw system for this. So let's actually create a draw system. and then we'll call that from here. So I've been going back and forth on whether or not I want the draw systems to essentially be structs. It could be helpful to have them be a struct, but at the same time, like I'm not like 100% certain that I want them to be like have their own storage. So if I just make this a function, so pub function draw system, we know we're going to take in a context. We also know we're going to take in the world, which is just going to be a reference to a world. We're going to return a error result, nothing in it. Okay, so we need to query the world for all of our we query the world for the entities that we're drawing out. So we let in this case we need the mesh and the locations. So locations, meshes, that's equal to, so I have a macro. I wonder if it's gonna be able to find it. It did, and it brought it in. Nice. Okay, so the query macro takes in the world, this query entity, and then all the components we're looking for. So world, the query, and then whatever components we want. And I think yeah, it is strings. So in this case, we want a location, and we want mesh. And there we go. Now we have a vector of component data. So much nicer than our previous queries. So now we can loop through either our meshes or locations. It doesn't really matter. Or we can do this in a try for each. I think now that I'm returning this type, it should be fine. Let's do a meshes iter. I'm gonna do a try for each. This is gonna give us, oh, we need to enumerate too. So in here, we're gonna get the index and we're gonna get the mesh. And then we have to return okay at the very end. All right, so what's gonna happen for us? Oh, I guess like it's not gonna work out the way we really want it to, is it? Because the result is gonna be just a subtly different type, I believe, but we'll try it. So I want to now for each mesh, we're gonna draw this out. So we need the location too. So let location. We also need to cast this, and I don't think we have like a special cast or anything else. No, that was the macros we created were just to like handle all the different types. So you're gonna be a reference to a data wrapper with a point inside. That's equal to our locations index. We're going to cast. Type annotations needed. Cannot infer type. Oh, probably for the return. So can I do Oh, but I have to do like dynamic dispatch, right? For like what the return is gonna be. Oh, like, okay. Success and then the error type, the result. So can I just say it's this result? Which inside will be that. Expected unit type. No, okay. Yeah, this is the problem I keep on running into when I try to use try for each with like custom results or like error results. I never can seem to get it working just the way I want it to. And I wonder if it's because like this. Because if I do an unwrap, okay, like that, you're not happy. Okay, so what do you actually need? Okay, so the function is here. And the result type. Okay, so the function is going to be a tuple. Oh, I have to like then give it the type. Oh, this is not fun. I don't want to have to do this. Because I would like to just be able to do result like that here, and then here we have to do like a closure type. What is it? F1 FN with like a U32 use size and a this is component data. Reference to component data. And then we need dyn in here. Okay, yeah, this is just too much. Okay, I'm just gonna do a normal for loop then. So for is just like a lot easier. I just do for index and mesh in a reference. I actually don't need the reference. In meshes, iter, enumerate. And then I can just use my question mark as normal in here. So we can recast our mesh. It's gonna be a reference to a data wrapper with a mesh inside. So cast u. Point. So this is going to be our locations, index, cast u. All right, so we have our mesh, we have our location. That means we can now, I need to pull you in. Okay, perfect. We should now be able to draw this. And these are RC ref cells, so we can just borrow them and deal with it. So we're gonna do a graphics draw. So pass in the context, pass in a, this is gonna be weird. So we have to dereference the mesh to get, and then borrow it to get at it. But then it wants a reference to it, so then we have to reference it again. And it can't really handle the ref, because that's the wrong data structure for it. And then our draw params. So draw param, create new draw params, and then we'll send it to the destination, which is our, so same thing here. We need to location. We need to borrow it, but then we can to array that. And I don't need to do any of the fun like asterisk this, because auto dereference in here, and it doesn't want a reference to an array, it just wants a full array. And we question mark and semicolon, and that should work. So now we have our draw system. We want a draw system, pass it in the context, pass it in a reference to self.world, and we unwrap you because you're not compatible with this type of game result. All right, and I think we're good here. Which means let's run this, see if we got a little red circle. There it is in the top left of the corner. Perfect. And it even like handled being in the right location for the redraw. I guess like not drawing for the first few frames is sort of like loading could be a way to optimize for that, but I'm not going to really care right now. So what do I want to do? I want to create a whole bunch of these and have them sort of moving upwards. What that means is, well, I guess let's have it. Let's give it the animation of moving upwards. So we have location. We're also going to have to register a velocity and an acceleration. And you'll be a velocity, acceleration. For velocity, we're going to start you off with zeros. For acceleration, we can give it like a little bit of a kick right to begin with. We can just have it be moving up. So let's do like negative 1.0. I don't know, that might be way too fast. Okay, so then once we have that, let's go ahead and add these components in. So with components, velocity, okay, so added those components in. Nothing else should really change here, but we need a new system for updating like the physics update. So what are you yelling about? Data, we don't need you, and I don't need the C size. Okay. Perfect. Let's go ahead and create a like update movement. All right, so same sort of general idea here. Have a pub function, update movement system. We're going to take in the world, which is in this case a reference to a world. We don't need to sort of get mutable reference to it because we have mutable interior mutability with that data wrapper, which is the RC and ref cell. And I don't think I need anything else necessarily. So I'm going to return a result here. Nothing in it. Okay, so what are we going to do? We are going to query for, I guess we need the locations, the velocities, and the accelerations. So let query. Let's get locations, velocities, they're going to be equal to, I'm going to query. So world query, and okay, locations, location, velocity, acceleration. Okay. That should give us what these are. It should crash if we don't find it. In fact, we could just run this right now and we should have them. But it also shouldn't matter. Like if we get a crash, it'll let us know that, hey, we couldn't find this thing. Okay, so now that we have the locations, the velocities, and accelerations, we need to loop through them. That's going to loop through every entity, and we need to update. So for this doesn't really matter. Let's just do index and location in locations. This is still just an iter and enumerate. Okay, so location is going to be a reference to a data wrapper with a point in it. Okay, and cast you. You're also going to be a point. Going to be velocities, index, cast, and accelerations, or acceleration. Mr. Halsey, hello. How are you doing today? Live. Are you streaming later today, Mr. Halsey? Perkin, hey, Perkin G. Good morning, hello. You're doing well, you got up late. Oh, it is always nice to be able to sleep in. Okay, so we have our location of velocity and acceleration. Time to now do our math. Togglebit was streaming the other day, so I guess he just didn't stream today. Okay, so the idea here is that velocity will be updated by the acceleration, which means we have these are RC ref cells. We need to make them all mutable here. Oh, we streamed early. Okay, no problem. Oh, don't worry about interrupting. That's like half the stream is interruptions from me myself, so I don't mind any from you. Oh, probably not streaming today. You're doing some system updates. Ooh. System updates are always a crapshoot, it feels like. Okay, so we're gonna take the acceleration and we're going to add that to the velocity. So it's gonna be our velocity. We have to borrow you mutably, but then we have to like actually have it. So I'm going to star that so we actually have a copy of it. Then plus equals, we have to do the same thing. So acceleration, this can just be a borrow at this point in time. You hit 280 megabits, little b, little m, download Starlink and the OS X update. Oh, that is nice. Yeah, I was telling my parents about that because they live in the mountains in California and it's really like bad internet where they are. They signed up for it, but they haven't gotten it yet. All right, so we're adding the acceleration to velocity. Now we do the same thing. We do location borrow mute. That's plus equals to the velocity. So this is going to be velocity And now we only need to borrow it. And then finally, location's been updated. We want to reset acceleration, so it's not just constant acceleration. We can maybe like play around with it a little bit. So this is going to be, we want to take, I don't remember how that, let's see, we're going to do acceleration, we're going to borrow mute, and then I think, multiply scalar, 0, 0. So multiply the acceleration by 0, which should reset that for us. Apparently I don't need this to be mutable. Oh, cool. Okay, well, I'm happy with that. So interior immutability. Okay, so then we should be able to run this update movement system in our update here. We do this before the update. So this is update movement system, pass in a reference to self.world. Unwrap you. All right, let's try running this because we gave it that initial, there it goes. We gave it that initial acceleration. We should now be able to like create a whole bunch of these and like set them all down. All right, well, let's create a rand so we can create like just thousands of them. Or maybe before we do that, let's start the location like right below. So we need the drawable size. Like I know where this is, but I'm actually curious whether or not we're going to get the drawable size properly. So let's width, height, graphics, drawable size. So I want to start with our I don't know, let's put this in the middle somewhere. So this could be width divided by 2. And height, let's put it at height plus, I don't know, I forget like how big the mesh is. Oh, we have this right here. It is 5. So we can just put this at like 10 down. We can also put it at 5. That'll be just right below the screen. So if I do that and it's moving upwards, we should be able to see it show up from the bottom of the screen. There it is. That is not the middle. That is definitely not the middle. I am just going to, instead of like debugging that, I am just not going to have us go full screen. We're just going to do that. Now it should just be a 1920 by 1080 window here, and our particle is moving up from the center of the screen. Okay, so perfect. Now, I want to stress this. In order to create a whole bunch of them, I need to, what is it? We need to bring rand in. Let mute RNG equals rand red RNG. Okay, so for our location, let's give this a random x. So RNG gen range. I want this between 0.0 and width. And then height plus 5 should still be the same. Then also I want to do this like 1,000 times. So 4 and 0 dot dot. Let's do 100 to begin with. We're going to spawn 100 components in here, each with a random X location, but the same height. So they should all rise together. You know what? That's not fun. Let's have this initial acceleration be a completely different number. So that's going to be a... we can still do an RNG gen range. Let's have it be from negative 0.5 to negative 1.5. Okay, they're all the same color. We can even change that. We can have this red be g dot gen range. This doesn't need. Can I just do random? Just do random. And that will give us a random F32 between 0 and 1, and that's fine. Is it? No, it'll be too dark for some of them. RNG dot. Let's just go back to gen range. Gen range between like 0.5 and 1.0. There we go. Okay. So with that, we should now see 100 of these show up all across, or crash. Red main panicked at cannot sample empty range. Wait a second, where was that? Cannot sample empty range. Do I have a gen range where I don't put a range in? Is this the wrong one? Do I have to do negative 1.5 dot 0.5? The answer is yes. And so here's our 100 particles, all rising sort of like different rates. That's fine. If I wanted to make it look good, and you know, besides, why wouldn't we want it to make it look good? We don't actually have to give it an acceleration here. These can just be 0.0. Now we can create a new system to give ourselves acceleration. So we can just do call this accelerate system. All right, so pub function, accelerate system. We know we're gonna take in we can use random for this one. I don't think that's gonna be a problem. Let's take in the world. This is a reference to the world. I don't need to take in like RNG or anything else. I don't really care about that. So we're going to return a result. So let's query first. Select. In this case, I only need acceleration. And, this is pretty cool. What am I making? So what I want to do, I'm doing some experimentation with performance, specifically in our draw loops. So I want just a huge number of things that we're doing individual mesh draws for each of them. So I'm gonna take it until like it's the edge of the system, and then we're gonna do a what was it called? A flame graph on it to see how much of a percentage of the game time, the CPU time, or I guess like run time, really, because there's the GPU aspect to it, is being taken up by the by just drawing. And then we can like experiment with different ways to bring that down. So I'm also trying to make it a little bit nicer looking. So query, world query, acceleration. We have that. We want to loop through this. So for acceleration, accelerations, iter. Why are you yelling at me that way? Oh, you auto figure out that you don't need to be a tuple, do you? So it won't let me destructure with one. Oh, wait. I can destructure like this, can't I? Comma. That's how it works. Okay, got it. So then I can iter through here. Acceleration. It's going to be a data wrapper. Point inside to acceleration. Asked you. Once we have this, I want to increase our acceleration. Probably like the left and right a little bit. So like let's just sort of like a random point. So like a wind, a force is going to be a new point. For the X, I'm going to do a random minus 0.5. And then for this one, we're just going to do random. So it moves up a little bit faster than it moves left or right. And I think that's fine. Then we're going to say dereferenced acceleration. We have to borrow mute plus equals the wind force. And that's it. That's all we have to do here. What are you upset about? Do you not know what you need to be? Type annotations needed. Fine. F32. All right, then in here, accelerate system can come in here. Accelerate system and a reference to self.world. All right, so let's run this again. And now we should have them all moving at sort of like different rates coming up. And some of them moving to the side. Or nothing at all? Let's start you not at the bottom. Okay, so our location is like underneath here. Let's just start you in the middle of the screen. So height divided by 2.0. Wind blowing them down, it might be. I thought that it was a 0 between. Oh, you're right. Wind is definitely blowing them down. Haha. Plus 5.0. Okay. In our I guess our accelerate system, I need to make sure the wind is a negative random. Haha, yeah, that's kind of important. Really? You won't let me do a negative random? Okay, a negative F32. So if I do that. So that works. I was kind of hoping that you'd be a little bit less. Let's, in our update, we can handle that though by changing, so while timer, I think it's, check update time, context, we'll do 60. So we'll update you at 60 frames per second update wise, but we're drawing as fast as we possibly can. That's still really fast movement. Check update time is the one that I want. Yeah, okay, so that's what we want here. We need clearly to not do this. I guess we could create a RNG. Then for here, we'll just do a gen range. Gen range, I want between like negative. We want this to be like really small. So like negative 0.3 and negative 0.1. Let's try that. Let's see how this looks. It's a little bit better. Still really, really, really strong. Let's go ahead and make this like a 0.3 and 0.1. This may be too slow. There's almost no difference in here. So we can have this also. Now that we're doing that, we might as well make this be a gen range too. Range. We want this to be moving left at a rate of negative 0.02 to 0.02. It's like very, very, very subtle pushes. And I'm thinking that instead of just creating them all, let's actually do let's actually not create any of them here. But an update, we can create them here. This'll probably be better. I'm gonna create a function to create particle self. We're gonna return a result, nothing in it. All of this stuff can go in here. All right, so we're gonna create a location, create a velocity, all that stuff. We do need to grab the world out, so we can just do let world equals mutable self dot world. So to grab that out here, we need RNG. So RNG can happen down here. Width and height. So that means we need this down here. If we need that, then we need the context here. I somehow missed this. That's cool. And we don't need you. We just register a bunch of components. At the very end, we return okay. All right, so we're good here. Then an update. We want to, at the very beginning here, call self.createParticle and pass it in the context. Unwrap you. So every frame, we're going to create a particle in a random location, and it's going to fly up. Look at that terrible We're getting terrible frame rate already. And I guess if we want to make it like really look good, do I want them to fade out as it goes on? So like the color has to be updated. So that means we need to register a component of a color too. World dot register color. Down here, component. Oh, let's actually create the color here. So our color is just gonna be white. BBECS is the ECS that we made. Yes, it is. It is the ECS we made. Okay, so I want this color. Sure, you can be this like this red. We're gonna start with an alpha 0. I don't know. I guess we want to recreate a new color every frame. So like we can create it as, oh, right. Okay, I know. We're gonna set you. You can be a random color still. And then the alpha is gonna go down. Okay, so then your color, and our data is a color, which means we now need an update color system for this. So update color system. No, don't paste. Okay, so we want a function. Now I can paste. We know we need the world, which is just a reference to the world. Return a result. Nothing in it. Okay, so a query. We just need the colors. That's all I'm gonna care about here. So the colors, we learned that equals query world query color. Once we have that, then we're gonna loop through these colors. So for color, colors, iter that. Actually, can I just do this? Yeah, that looks fine. Then we're gonna cast this color data wrapper. You are a color. Cast you, and then we want to just make a little itty bitty change to it. I want to subtract 1 from the color. That's what I want to do until it becomes nothing, and then we're gonna have to. It's an F0, so we could just subtract 1. We should be fine. So we're gonna do a color dot borrow mute, and then we have the alpha minus equals 0.01. Just like very subtle like alpha change. And that's all we need to do right now. We should see them all fade out as we go, and then we can delete them from the world as they as we need to. So an update here, we're also gonna update color system. pass in a reference to self dot world. All right. Just to make you the same, just do that. And now if we run this, we should see all of our particles sort of fading out. No, they don't. You know, the reason they don't is because we need to update the draw system here. For the draw system, we need to add in a query for a, what is it called? The colors. Color here, grab you out. Color, data wrapper, color. It's gonna be colors, index, cast you. And then we want to set our color to be equal to a dereferenced color.borrow. Pull you in. All right, let's see if this works. I see them as red. I don't see them as fading out, but that doesn't mean that they're not fading out. It just might be that it's way too slow of a fade out. Something that we can do here is in our draw, I kind of want to do a debug of a dereferenced color.borrow just to see if these colors are fading. I want to see if this like alpha is getting really low or like close to 0 over time. So alpha is like 0.01, 0.0. Why is it going up? Going up. Minus 0.01. And when I create the color, your alpha should be 1.0. Oh, Danny Fritz, hello. I am subtracting a negative. Wait, really? In our update color system? Oh my gosh, you're right. I'm attracting a negative. Haha, yeah, that's fun. Okay, so there it goes. Now they're fading out plenty. So let's have it be like maybe 0.01. And then something we can do here is we can add in another thing in here. So we have colors, and let's bring in the IDs. So this is entity ID, and then if our if color borrow dot a, if that is less than or equal to 0, then we want to delete. So world dot delete by ID and pass it in. Oh, we have to actually like get the ID out. So let ID, it's gonna be a data wrapper of an U32 is index. Oh, we need the index then. Index, cast you that. Okay, so then we can world delete by ID. This is going to be a dereferenced ID. We're going to borrow you. And so then we have our update. So these should just disappear from the system as soon as they fade away. They are fading way too slowly now. Also, we should delete that that debug. Where did I put the debug? In here. In update color system, let's make this fade. 0.01 might be okay. What am I simulating? I'm sort of, it's not really anything. It's just like a bunch of particles flying up from the bottom. They're fading away. And we can see here that the doom fire, yeah, kind of like that. So they're disappearing. Now, if I allowed them last like a little bit longer, just a little bit longer. So let's do like 0.8. We're gonna get more particles on the screen at the same time. Okay, that's pretty cool looking. Now let's double the rate that we're creating these. So in our update, we have this create particle. We can just create this twice. Like every frame, we're creating 2 of them. And we're still fine. Okay. So let's do a quick for loop. So 4 and 0 ... Let's do 10. Every frame, we're going to create 10 of these. Okay, that is not very happy with debug mode. And I'm curious if I put this, because when we do flame graph, it's going to do it in production mode. Who needs frames per second? Exactly. You understand me. I'm gonna put this in release mode. I'll have to do a recompile. Frames per minute. Exactly. That's my games run on an FPM timer, not an FPS. FPM. Also, first-person shooters. We're totally gonna get it. Like, it's gonna be the new thing, right? What was the old arguments? You know, human eyeballs can't actually see at 60 FPS. You know, 2 FPM is really the most that we can see. Oh, and look at this. Switch over to release mode, and things are really happy again. So, let's try 15. This is still looking really, really nice. How about 30? I am actually shocked at how nicely this is looking. Okay. We can try, let's do 42. I'm not gonna do a million. Sorry, Danny. I'm pretty sure a million's gonna break it. Okay, 42 is a little bit too much for it now. If I wanted to print out what our frame rate is, we can do inside of this timer here, after we do our update. That is a ton, yes. I want to, if timer ticks context, every 100 ticks, that's 42 per frame we're adding. Yes, yeah, absolutely. If timer per ticks 100, You know what? I don't know if I have a way to count how many we have without a full query. We can do a query just to sort of like see what we're working with here. But I want to right now just debug timer FPS context. So every 100 frames, let's print out what our average FPS is. $25. We're gonna need 25 FPS. I mean, we're almost on last generation console. Oh no, now we're on 17. Never mind. Never mind. Is it gonna go down even further? Yeah, it's just dropping. Dropping like a rock. Okay, maybe stabilizing around 12. Almost 13. What's with the 4 standard out flushing? What am I doing with that? The 4 standard out flushing? Or 5? Oh, yeah, that's because I am doing this thing with my while timer. So what's that saying is I'm trying to have my target FPS at 60 frames per second. So it's getting slow enough that it has to run 4 of those to keep up with our target FPS of 60. It's interesting. So that way we keep, if you notice, we still had the smooth movement, even though our frame rate was so bad. It's actually really nice, clever trick. I want to switch to 200 because it's really the FPS over 200 frames. And then while we do this, I don't think we have a way to grab out of the world like the number of entities that exist. So we can just do a really quick query. This is gonna be the IDs. Query. So self.world query and entity ID. And then I just want to debug the count for this. So it's going to be IDs dot length. And that's going to be how many exist. So how many of these exist? $5,208. That's how many exist in the world at any one time. Let's see if it increases. No, it's heading steady around that. Okay, perfect. So if I wanted to do the flame graph, I don't necessarily remember. I think it was like cargo flame graph. Oh, wait. No. I can't. Oh, I have to do this on Right, never mind. I can't do this right now. I have to do this on my Linux system later. So I'm gonna run the flame graph later, and then tomorrow morning we'll have access and we'll go over this and sort of like come up with a list of like what are strategies that we can like handle this. And I don't have time this morning to spin up the what is it, our virtualization with Ubuntu and like try it there. Also, I want to do this like on an actual Linux system as opposed to like worrying about a virtualized environment not working properly. So I am gonna go ahead and end the YouTube part of the video here.